Here you see, in the form of a 3D project presentation, a complete cement grinding plant equipped with an LM 56.3 plus 3C for 260 tons per hour OPC. This modern CAD method is the current state-of-the-art at Löscher for the planning and design of entire plants. What we are now going to show you is a flow sheet of a cement and blast furnace slag grinding plant using an LMCS Löscher mill. The number of bunkers reveals immediately that both single components such as cement clinker and blast furnace slag can be processed, as well as mixtures of these in combination with aggregates. Dry cement clinker is drawn from this bunker by a conveyor-type weighing machine. On the subsequent conveyor belt, foreign ferrous matter is separated by a transverse magnetic separator arranged above the belt. Non-magnetic metals are removed by a metal detector. These non-magnetic metals are disposed of by deflecting material from the belt. The material to be ground, now free from foreign matter, continues along a further conveyor and goes through the rotary valve and arrives in the Löscher mill. Moist material to be ground is treated in a similar manner. Extremely fine and dry aggregates, in particular fly ash, are fed from a separate bunker into the mill through separate conveyor lines. Grinding aid stabilizes the grinding bed and is used at the request of the customer. The water injection system is intended to condition both the grinding bed and, if required, the hot gas flow. The necessary process gas for the mill is produced by a hot gas generator. The flow of hot gas dries the ground material and conveys it to the classifier. The mixture of gas and pulverized material leaves the classifier and is separated downstream in the filter. The clean gas is discharged through the chimney. For energy-saving reasons, part of the process gas flow is recirculated to the mill via the hot gas generator. The fan conveys this gas through the entire plant. Any coarse material rejected by the mill is recirculated by means of a bucket elevator to the long conveyor belt of the reject system. The principal element of the above described grinding plant is certainly the Löscher mill with its classifier. Here are the main components. An electric motor serves as a drive for the mill gearbox via a coupling. The grinding table is supported and driven by the gearbox. The material to be ground flows over wear-resistant grinding plates that are installed in the upper surface of the grinding table. The grinding bed is crushed as it passes beneath the stationary rollers. Cement clinkers and blast furnace slag must be crushed to grain sizes of between 2 and 50 microns. These ultra-fine products, in the form of dust clouds in a highly aerated condition, can only be kept under control by taking special precautions. The grinding bed is de-aerated and compressed by small preparation rollers. The actual grinding is performed by large grinding rollers under the application of high pressure. All rollers, mutually independent of each other, are precisely guided in rocker arms and are supported by the structure of the mill. The grinding table sits in a gas ring duct that is supplied with hot process gas through the gas ducts. The hot gas is directed into the grinding chamber through a louvering. The rejects drop through the louvering into the ring duct and are removed by the rotating scrapers. The ground material is dried in the hot gas stream and is conveyed to the classifier. The finished material passes the classifier and the mixture of gas and pulverized material flows through the ducting to the filter. Oversized material is rejected by the classifier. It drops through the grit return cone back onto the grinding bed, where it mixes with the feed that is supplied to the mill through the rotary valve and the feed chute. Löscher mills are conceived to be service-friendly. The gearbox and rollers can be installed and removed without dismantling the mill. The grinding plates, with swing-out rollers, are also readily accessible for quick exchange. The components of the hydro-pneumatic spring system for the rollers are installed in a pedestal outside the grinding space, where they are also freely accessible during grinding operations. Here you see the interaction of the preparation roller and grinding roller, and also the water injection between the rollers. The schematic flow lines mark the route of the hot gas from the gas duct through the louvering into the grinding chamber. A classifier, a type LSKS dynamic classifier, is installed on top of the mill. A static guide vane ring surrounds the caged rotor inside. The rotor is driven by a motor and gearbox unit. The modular structure of the Löscher mill permits separate servicing of each single roller. In the swung-out position, grinding components or rollers can be quickly exchanged. And this is how the particle flow develops in the grinding chamber and inside the classifier. The Loma firing system was developed by Löscher in the mid-60s. It consists of a firebox made of high-temperature steel equipped with a small muffle. The process gas passes through the spiral casing into the firebox where it is heated up. It penetrates through the annular gaps and boreholes of the perforated shell into the center of the firebox named Loma heater, where it mixes with the hot flue gases. The steel shells are cooled by the process gas flowing through the firebox to the effect that a refractory lining need not be provided. The technology of cement clinker and blast furnace slag grinding in roller grinding mills has been introduced by Löscher. It saves both energy and material resources and is environmentally friendly.